All right, hello Algebra 2. Let's go over our 9.6 samples in preparation for our last quiz in Chapter 9, where we're solving triangles using the law of cosines as well as the law of sines, as well as the fact that the sum of the three angles in a triangle sum to 180. All right, so our first triangle to solve, we're given the information that angle C is 48 degrees, and side A is 17, and side B is 20. So when we draw the picture, we realize this is an SAS triangle. We have an included angle, which means we will not be able to start by using the law of sines because we don't have any ratios that will give us enough information to use the law of sines. So instead, we're going to start with the law of cosines to find this length here, side C. So the law of cosines for side C says that c squared is equal to a squared plus b squared minus 2ab times the cosine of c. So we're going to plug all those numbers in. For a squared, we plug in 17 squared. For b squared, we plug in 20 squared. Minus 2 times a is 17 times b is 20 times the cosine of c, which we're told is 48 degrees. All right, and then we go ahead and simplify what we can before we use our calculators. We can use our calculators at this point, but we're likely to make errors, typically if we are plugging in all of this information. So 17 squared we know is 289, so I'll simplify that. 20 squared is 400. 2 times 17 times 20 is 680. Everything else I'll leave the same at this point. Then I'll add 289 and 400, and that will give me 689, and I'll leave the minus 680 times the cosine of 48 degrees. This is as simple as I'm going to make it to find my c squared. I'll use my calculator at this point to plug in 689 minus 680 times cosine of 48 degrees. That will give me 233.9911 and some other digits past that. That's my c squared value. Then I'll take the square root of both sides to arrive at how long c is. I'll round it off to the nearest hundredth, and that will give me c. The length of c is 15.30. Okay, so I know the lengths of all three of my sides at this point. Now I'm going to, instead of using the law of cosines again, which I could use, instead I'm going to now go to the law of sines because I have enough information to be able to use it. Law of sines is simpler, and usually it's going to be a little bit more efficient to use the law of sines when you have enough information for it. I will pick the angle that is opposite the shorter side of the two choices I have left to make sure it is not an obtuse angle, so that when I find the angle measurement using my sine value, I will know I'm getting the angle that is in this triangle, not the obtuse angle. Okay, so I'm going to use my C is 15.30. I'm going to use sine of 48 degrees over 15.30 because that is sine of C over C. And that's equal to sine of A. I don't know A yet. That's what I'm trying to figure out. Over 17. So that's sine of A over A. This is sine of C over C. And now I can solve for my A. So first, sine of A is equal to, using cross product, 17 times sine of 48 degrees divided by 15.30. Using my calculator, sine of A is 0.8257 and some other digits beyond that. I will then find the inverse sine. So sine inverse of 0.8257 will give me my A, that is angle A. So A is 55.66 degrees. I now know how long side C is. I now know the angle A is. The only thing that still remains to be figured out is angle B. At this point, I will use the fact that the sum of all three angles in a triangle is sum to 180 to find out my missing angle measurement B. So if I take 180 degrees minus my known angle C, 48 degrees, minus the other angle measurement A that I figured out that was 55.66, that will give me the angle measurement for angle B, which is 76.34 degrees. And that completes this problem. I found all the unknowns. I found how long C is. I found out angle A and angle B's measurement. Here they are. So I am done with this problem. One more sample. Solve triangle ABC knowing the lengths of all three sides, but not knowing any of the angle measurements. So our job is to figure out what is the measurement of angle A, B, and C. We will use the law of cosines again to start because we don't have enough information for this law of sines to determine any of these angle measurements. So we're going to pick the angle that is opposite the longest side to start in case that angle is obtuse. So that way we will get an angle measurement by the law of cosines if it is an obtuse angle, guaranteeing that the other two angles would have to be acute angles, and using the law of sines and the fact that the sum of the angles in a triangle at a 180, that will give us correct information. If, in fact, this longest side here is not opposite an obtuse angle, if it happens to be acute, we will still get accurate information. But again, the other two angles would, of course, have to be acute as well, so that when we use the law of sines, we will be getting information from our calculator that is, in fact, the angle that is in the triangle. All right, we begin. So we're going to start then by using c squared, because that is the longest side. So we'll use the law of cosines that deals with c squared. So c squared, 12 squared, equals a squared, 10 squared, plus b squared, 3 squared, minus 2 times a times b. So that's 10 for a, 3 for b, times the cosine of c. So we're going to find out that angle measurement for c. Let's simplify. 12 squared is 144, 10 squared is 100, 3 squared is 9, 2 times 10 times 3 is 60. All right, and then simplifying further, 144 equals 100 plus 9 is 109. We'll just bring that minus 60 cosine c down. Then subtracting 1 on 9 on both sides gives us 35 is equal to negative 60 cosine of c. Dividing both sides by 60 gives us negative 35 over 60 equals cosine of c. You can use your calculator at this point with this fraction. I prefer smaller numbers where possible, and since this does reduce down to negative 7/12, dividing by 5 over 5, I've chosen to reduce this fraction to negative 7/12 equals cosine of c. Then I'm going to use my inverse cosine function to find c. So cosine inverse of negative 7/12 is c. And on my calculator, that will tell me that angle c is 125.69 degrees rounded off to the nearest hundredth. Now, again, I could continue using the law of cosines to find my other angles, but I'm going to choose to use the law of sines because it's simpler at this point, and I can. So I know my angle C. I know it is, angle C here is 125.69 degrees. So I'm going to do sine of C over C. That's sine of 125.69 degrees over 12 for C. And that's equal to sine of B, and I don't know that one yet, over 3. All right, so using cross products, I'll have sine of b equals 3 times the sine of 125.69 divided by 12. Using my calculator, I'll find sine b is 0.2030. That's plugging in 3 times sine of 125.69 degrees divided by 12. Then I will use sine inverse to find angle b's measurement. So sine inverse of 0.2030 equals b. And then I will find that b is equal to 11.7151, which rounds off to angle b is 11.72 degrees by the law of sines. So I know 2 of my unknown angle measurements. By the law of cosines, I found angle c. By the law of sines, I found angle b. Now, I could use law of sines again or law of cosines, but I'm going to use a simpler fact, and that is that the sum of the angles in a triangle sum to 180 degrees. So to find A, I would take my total, 180, minus the 2 other angles that I already know, 125.69 minus 11.72, and that's going to give me my last angle. Angle A then is 42.59 degrees. And that concludes this problem because I have all these unknown angles now determined, and I already know the 3 sides because that was given information. So that concludes our sample practice where we have SAS or SSS triangles, where we use the law of cosines to begin with to begin the process of solving for our unknowns. All right, make sure you have this in your notes and use this as a guide as you are working on your quiz for today. See you next time.